Okay, power supplies are taped together, and this is where our heavy duty wire comes in. So I'm going to cut off enough of this wire so that I can make a jumper that will go from here to there and another one from there to there, so that I'll have 0 volts, 12 volts, 24 volts. So I'll cut that and bend the ends and take it from there. Okay, it's time to connect the positive with the negative, and you'll want to make make a couple of jumpers. This one, this is the other one. Here's just kind of what it looks like. So basically, you have to make that to fit into the clips, and when you work it in there, you get it the right size, and you work it in there with a screwdriver, it'll snap right in like this one is here. And after you've got both of those made, you can pull them out. Okay, I like to apply a little bit of this flux on here, because solder does not stick well to copper that has been oxidizing for who knows how many years. This one, I think I missed it. Let's get some of that on there. And then reinsert these jumpers. I like to use a screwdriver to kind of spread these apart. You can insert one end like this, and then the other end's the tricky one, and I usually end up just kind of using the screwdriver to pry open the connector there, and it's hard to do with a camera in the way. I'm left-handed, but there it goes. Alright, and let's do the other one. It's actually a bit long. Okay, insert this one the other way. And you just need to work at this until you get it all together. But there we go. That looks pretty good. And I'm just going to try to make this a little bit more straight. Like that. Alright, that's pretty good. And then I like to hit it again with rosin. This liquid rosin just makes the solder flow so much better. It's just worth putting a little more on there, like that. Alright. Then I take our soldering iron, and a bit of solder, and I won't go into all the tips and tricks on soldering, but basically I'm going to put some heat on this, and I want that rosin to smoke quite a bit, because basically it helps it do its job. Get the terminal pretty warm, and then I'm going to start melting solder on the copper, not on the tip of the iron if I can avoid it. Easier said than done, I'm afraid, because I'm trying to do this with the camera in the way. And that might be a pretty good joint. That is the easier one because it is on the outside. Again, let the rosin do its job. Start feeding in solder. By the way, my iron is variable temperature and it's set to 600 Fahrenheit. That looks like a perfectly fine joint. I'm not in a hurry. I'm just enjoying some easy soldering. And the first time I did this, it was not easy, because I did not have the liquid rosin. So if you're struggling, you may want to consider the liquid rosin as a possible solution. And this is just really difficult. Okay, there we go. Alright, let's clean the tip a little bit. Do this one. When it gets hot enough, the solder will just flow. And I'm using a rosin core solder also. Alright, I'm going to let that cool. And then tug on these wires and see if there's a good connection. This side's already done, so that is solid. That seems really good. Alright, I am satisfied with those, and I'm going to do a good visual inspection here, and it looks, those all look like good solder connections. Okay, so that is done. Okay, so this power supply is done. I'm going to power it up. Alright, and I've got my meter, DC volts, and like I said, this is the minus terminal, this one or this one. It's the minus, or 0. This is going to read 12 volts. It does. Of course, it's the same voltage over here because it's jumpered. And then if we go all the way over here, we've got almost 25 volts. And since the charger can take more voltage than that, this power supply is ready to power the Hyperion. So we go to the field, we have our charger, we have our power supply, and the first thing you do is you connect the power supply to the charger, and then you can plug in the power to the power supplies, and that will start the charger. Then you want to always connect the large ones, wires first. You don't want to connect the balancing connector first, so large wires first and last. I'm not even going to push it in all the way. Balancing connector. Let's put it on the correct one. There's only one that's going to fit. And now I'm going to demonstrate that this configuration will indeed charge the battery at 20 amps. So I've got a charge current of 20 amps set up. I'm connecting a 6S. This happens to be Turnigy, the way I programmed this, but Turnigy 6S, 5,000 milliamp hour, 4C is my charge rate for this pre-programmed channel. 4C is 20 amps. I hit enter, hold it twice. I'm going to see the battery charging after I accept that. You see the charge current go up to 20 amps. Our input voltage is 23.4. Got 4 or 5 amps now going out to the battery. Alright, we've gotten all the way to 9 amps. So we've cleared that 11 amp limit I talked about before, and I'll demonstrate that next. So with this 24 volt nominal input, the charge current is ramping up, and we are at the limit of 20 amps. Okay, and then it's going to take a pause here and check the cells, and it's going to start charging again. It's totally normal for this charger. 20 amps. So 20 times 24, we've got 480 watts output, and probably consuming 5 to 550 on the input. So I'm going to stop the charge. I'm going to disconnect the power to the power supplies. Okay, and then I am going to switch over to a 12 volt input. All I need to do is just move this clip over to that other wire. Okay, I'm on 12 volts. Power back up. Bad connection there. So I'm at 12 volts input. I'm going to try to charge it at 20 amps. Now let's see what happens. I think it will go up to about 11 amps output, because at 12 volts input it just cannot output more current. Eight amps, 10 amps, and there you have it, 11 amps. It's just not going to go any higher than 11 amps. And so it's got 24 volts output to the battery, but it can only go 11 amps charge current. So there you have it. A working power supply for this battery charger that lets the charger run at its highest limits if it needs to. So earlier I showed that you would need a Sharpie or some kind of a permanent marker for this project, and you didn't need it just for that spacer that I used it to put the washer in. What you really also need it for is to label these terminals. So you've got minus, plus 12, and plus 24 volts. So if you want a 12 volt output, this would be positive, which is red, and your black would go here on negative. If you want 24 volts, you would have your red here on the plus 24, black on minus. So really, this is a dual output supply, 12 volts at 41 amps, or 24 volts at 41 amps. Amps do not double, because these are in series. So you'll have two cords with two connectors for the power supplies, and the other ends go in the power outlet. But you'll consume an entire outlet using these. So what I like to do is get one of these T adapters. So when you go out to share the space with other people using power supplies and battery chargers, you can just use the one outlet in the duplex receptacle. You heard the sparking when I connected these alligator clips to these terminals, and actually I had it connected when it was sparking. I had it connected here to this 12 volt wire. Jeez, I can't get it on there. This 12 volt wire like that, and it wasn't a good connection. To make this a lot easier, what I would do, and I'm not going to do it in this video, but what I would do is I would pull these off and store them somewhere, and buy a couple of female bullet connectors that are this size and solder those on the power supply. I would maybe do 1, 2, and 3 just so you have 12 volts and 24, but then you could just take these and plug them in and everything would work the first time every time. Next we'll need to cut this tubing into 1/4 inch lengths and make 8 pieces. When connecting to this power supply with these alligator clips from the charger, if you connect to this inside one, the one near the small pins, there's a risk that there will be a short circuit between the pin, this clamp, and this first row of the small pins. So to protect these 4 pins, we can put heat shrink over them, and then I still recommend using the outside pin only for connection if you're going to clip to these pins. So to protect the small pins, we can just take the heat shrink tubing that is a 1/4 inch long and slip a small length of that over each of the 4 pins, and we'll do the 4 on this side and the 4 on the other side. You shrink those down with a little bit of this lighter flame, and it is done. And even though the tubing has been shrunk, it's still not tight enough around the pins. And to give it a little insurance to not slip off, I'm just going to apply a little bit of silicone sealant, and you can use latex sealant also over those pins, and that will assure that that tubing's not going to slip off. It's not the prettiest solution in the world, but it does the job. And this is the completed power supply with the jumpers and the silicone with the 4 heat shrink tubing over each of those 4 pins on each side. I've got clearance to the first pin for connection if needed. And this is complete and ready for use.